All right, guys, go ahead with the top review problem. Go ahead. Okay, so you can check your work up on the board. You should end up with 3x squared plus 4x minus 15. And today we're going to learn how to undo this. So remember, we've been practicing a lot of different ways of undoing distribution and double distribution. But to this point, we haven't looked at any problems with a number in front of x squared that we couldn't get rid of. So let's look at what we've done up until this point. So to this point, we've done problems like, let's see, x squared plus 7x plus 12, where there is no number out in front of x squared. So I just simply find the factors that multiply to 12 to add to 7, which would be 3 and 4. And then as I'm creating my parentheses, I've said several times this x squared is where the x and x come from, right? So we have x and x. And then our two factors would be plus 3 and plus 4. Okay, we've also looked at some problems like this, like 2x squared plus 14x plus 24, where there is a number in front of the x squared, but what have we done with it to this point? Yeah, we take it out because it's a GCF, right? So this one would have a GCF of 2. I divide it out of every piece, and I'm left with x squared plus 7x plus 12. And I could, again, inside the parentheses, now I kind of ignore the GCF outside. Now there's nothing in front of x squared, so I make my two parentheses there. Okay? But we haven't looked at any problems in particular that we can't get rid of the number out front, like this one. So say, remember we are thinking about working backward today. So if I start with a problem like this, there is no GCF that's going to get rid of the 3 that's in front of that x squared, right? So if you look at the relationship between this and our final answer, right, if we're working backward, that top line would be our final answer. Now we have a number in front of x squared, right? Up to this point, when we factored, all of our parentheses are always x plus or minus a number and x plus or minus a number. There's never been a number in front of x. Today we're going to learn where that number in front of x goes, which set of parentheses does it go in, does it break up and go into both, what happens with that, okay? It is the same process that we've used before. There's just a couple added steps. There's one added step in the beginning and one added step at the end, okay? If there's a number in front of x squared that you can't get rid of. All right, so let's jump into an example and look here, okay? So example 1. So you still go through the same factoring checklist. Is there a GCF? So is there a GCF on example 1 that divides out of 3, 4, and 15? There's not. Okay, so I'm stuck with a number in front of x squared. So this is when our new method kind of kicks into gear. So we are used to now just finding the factors of negative 15. But that's because there was nothing in front of x squared. Now that there's something in front of x squared, we actually need to multiply a times c and find the factors of that. So a is 3, c is negative 15. So what is 3 times negative 15? What is AC?
Negative 45.
Okay, negative 45. Okay, so let's pull over to our listed out steps over here. So the first thing we want to do, step 1, is multiply the A and C. Okay, and now we're used to finding numbers that multiply to our C value and add to our B value, right? That's what we've been practicing. But now we're going to find, so the same type of deal, what multiplies to this new AC number, but it's still going to do the same thing. So it still needs to add to B. Okay, and then once I find those factors, they go into my parentheses. So this is the part that should look familiar. Once I do A times C, and I find that number, now I'm finding the factors of that add to the middle. So I still need to add up to 4. So factors of negative 45, that would be negative 1 and 45, or 1 and negative 45. Those don't add up to 4, so let's keep going. 2 doesn't go into 45, 3 does, so negative 3 and 15, or 3 and negative 15. Those don't add up to 4, so keep going. 4 doesn't go into 45. 5 does, so negative 5 and 9, or 5 and negative 9. Which pair adds to 4? Negative 5 and 9. So just like I'm used to, those go straight into my parentheses. So I have x and x, negative 5 and positive 9. But remember, when we start with a number in front of x squared, we're going to end up with either one or two numbers in front of the x's in my parentheses. Okay? So I can't just stop here. So up to this point, the only thing that's been new is multiplying a times c. The same process happens after that. We find the factors of that add to b. They go into our parentheses, but now we have to take into consideration this number in front of x squared. Okay, so now I need to take into consideration this 3 right here. And I do that by dividing it out of both of the terms that I put in the parentheses. Okay, at this point we need to divide or reduce if we can. If we can't, that's how we know we're going to have a number out in front of x. So does 5 over 3 divide or reduce? It doesn't. So this 3 is going to slide out in front of x. So this set of parentheses is 3x minus 5. So if there is a denominator in your fraction, after you've divided or reduced, it slips out in front of the x. Okay? What about the second set of parentheses? Does 9 over 3 divide or reduce? It does. What's 9 divided by 3? 3. So this piece back here is just going to be 3. You see there is no denominator left? So this set of parentheses is just, oops, messed up, sorry, x plus 3. So there is no number in front of x there. And that's my final answer. So one added step in the beginning, you got to do AC. One added step at the end, you got to divide by A and then deal with the denominators if there are any. Okay, let's look at another example here. Okay, so is there a GCF? There's not. So I have a number in front of A, so I have to deal with it, right? So now I'm going to do A times C, so 3 times 3 is 9. And I want factors of 9 to add to negative 10. So I have 1 and 9, or negative 1 and negative 9, or I could do the 3's, but I don't need to, right? I already found my pair, negative 1 and negative 9. Those go straight into my parentheses. So V minus 1 and V minus 9. And now I divide by whatever the A value is. So whatever the A value is, I have to divide by that. Oops. Ah, man. Sorry, I'm making mistakes today. Divide my numbers by whatever that A value is. And now divide or reduce. So does 1 over 3 divide or reduce? It doesn't. So that 3 value slips out front. Does 9 over 3 reduce or divide? It does. 9 divided by 3 is just 3. So my first set of parentheses, the 3 slips out front, so 3v minus 1. My second set of parentheses divided out, so it's just v minus 3. Okay. So if there is an A there, you have to take it into consideration in the beginning and the end. The same process happens in the middle. Alright, so in the beginning you got to take it into consideration by multiplying AC, and then at the end you got to take it into consideration dividing it out of your factors. Okay, can I get a comfort level of how you're feeling? Good. Okay, let's go ahead and do the 4 try these problems. So A, B, C, and D together with your groups. Go ahead. Hey guys, let's take a pause for a second. Let me address something in A that we didn't. I know you're probably not done. That's okay. But let me address something in A that didn't happen in our first 2 examples. So let's just work through A, and then I'll give you more time to do B, C, and D. Okay. So there is no GCF. So AC here is 60. Factors of that add to 19. So I start with 1 and 60. That doesn't work. 2 and 30 doesn't work. 3 and 20 doesn't work. And then I make it to 4 and 15. Okay. So I have n plus 4 and n plus, sorry, not 15, 20. No, it is 15. Ugh. My brain's not on track today. So n plus 15. Okay, I need to, again, take into consideration the 20. So divide each of those by 20. And earlier I said you need to make sure to divide or reduce. I'm not sure everybody got the reduce memo. Okay, because the first two examples that we found either didn't do anything or divided out nicely. These don't divide out nicely, but they do reduce, right? So what can I divide out of 4 and 20 both? 4. So this actually becomes 1 over 5, right? So it reduced, but the 5 still has to pop out front. 15 over 20, what divides out of both of those? 5, and I'm left with 3 over 4. So again, the 4 is going to pop out front. So this would be 5n plus 1 and 4n plus 3. So you do have to make sure to reduce those fractions even if they don't divide out nicely. I don't just plop the 20 out front and leave it alone, okay? So I just wanted to address that quickly. Go ahead and finish B, C, and D. Okay, guys. All right. So does B have a GCF? No. So I start by multiplying A times C. So 6 times negative 3 is negative 18. I want factors of that add to 7. So 1 and 18 are not going to work. Negative 2 and 9 or 2 and negative 9. 2 and negative 9 works, right? So that goes straight into my parentheses. C minus 2, C plus 9. And then since I had a number in front of C squared that I couldn't get rid of, I divide both of the factors by that. So 2 over 6 reduces to 1 over 3. 9 over 6 reduces to 3 over 2. And the denominators that are left slip out front. So I am left with 3c minus 2 and 2c plus 3. Okay, questions on B? You're going to have to go back and watch notes. Yeah. Any other questions? We good? Okay. Let's look at C.
What was the answer for number 2?
3c minus 2, 2c plus 3. Oh, my bad.
That is wrong.
You broke my brain.
Yeah, no kidding. Should be a 3C.
I'm sorry.
1, 2C. Okay,
I apologize deeply and wholeheartedly. Now I can't even erase it, so I have to do this.
There's some of that.
I know. All right, thank you guys. Sorry. Good catch. Okay, so let's look at C. Okay, is there a GCF on C?
Yes.
It is
5.
5. So I divide a 5 out. So 20x squared divided by 5 is 4x squared plus 16x plus 7. Okay, so the 5 is just going to hang out front. Now I look inside the parentheses. I still have a number in front of x squared, so I still have to do AC. So A is 4, C is 7. So 4 times 7 is 28. Factors of 28 to add to 16 would be 2 and 14. So the 5 is going to hang out front, and then I set up my two parentheses, x plus 2 and x plus 14. Okay, I still need to take into consideration this 4 right here. So I divide each of my factors by 4. You don't divide the the GCF by it, okay? So let's go ahead and reduce. So this would reduce to 1 over 2. This would reduce to 7 over 2. So the denominators, again, pop out front. So the 5 hangs out front. I have 2x plus 1 and 2x plus 7. Dunzo. Okay, one more. Let's look at D. Does D have a GCF?
Yes.
It does. What is it?
2.
2 what?
Oh, 2 in.
N. They all have an N, right? So 2N is my GCF. Okay, which leaves me with N squared plus 7N minus 60. Do you notice what happened inside the parentheses? There's no number, right? There's no number in front of n squared, which is nice because we don't have to do the added step of AC. We don't have to do the added step, of dividing at the end. Okay, so I'm just finding the factors of negative 60. The add to 7. So what? 1 and 60 is not going to work. 2 and 30 is not going to work. 3 and 20 is not going to work. 4 and 15 is getting me closer, but not going to work. 5 and 12. So negative 5 and 12, or 5 and negative 12. So the one I want for positive 7 would be negative 5 and positive 12. So again, the 2n is going to hang out front. And then I have n minus 5 and n plus 12. So since there is nothing in front of n squared, I'm done. Okay? So all I did was make your process a little bit longer for those problems where you can't get rid of the number in front of n squared. There's just one added step on the beginning to do AC, one added step at the end to divide it back out. Okay, any questions? Cool.